So here we've got three different graphs plotted against concentration of a reactant, which we'll call A, against time on this first graph. The second graph has the natural log of the concentration of A plotted against time. And the third graph has the reciprocal, or the inverse, of the concentration of A plotted against time. You'll notice all three of them are straight lines, and I don't really want you to put too much thought into why this is concentration, why this is natural log, and why this is the inverse or the reciprocal, because they have been integrated using calculus, and that's really above what we need to know. But what we do need to know is the relationships between these. So if we take a look at this first one, so we have time down here at the bottom. As we move forward in time, a reaction is progressing. And let's just say our reaction is A making B. It makes sense that if as the reaction progresses, A turns into B. If A is turning into B, then A, the concentration of A, should decrease as this reaction progresses because A is getting used up. So for that reason, we have a negative slope here, and you'll notice this is a straight line. In this situation, when the concentration of A is plotted versus time, if the line is linear, this is zero order with respect to A. The concentration of a reactant will only plot a straight line versus time if it's zero order with respect to A. On the second graph, if you plotted the natural log of the concentration versus time and it formed a straight line, this is first order with respect to A. In other words, this can only occur, it can only be a straight line with the natural log of A if the reaction is first order with respect to A. And then over here, we have the reciprocal of A, and since it's been inversed, it does make sense that this line is going up instead of down. If the inverse or the reciprocal of the concentration of A, in other words, 1 over A, forms a straight line when plotted against time, that is second order with respect to A. All three of these cannot be true for a given reactant, only one can be true. Either you will plot the concentration and it makes a straight line, or you will plot the natural log and it make a straight line, or you will plot the reciprocal and it makes a straight line. And this will indicate to you whether it's zero, first, or second order with respect to A. You're simply looking for whichever line is a straight line.